Hello water managers, I'm Fauwaz Hanbali with the Water Management Systems Division at the Hydrologic Engineering Center. I'm going to cover the HEC-MetVue overview presentation. In this part of the presentation, I'll introduce some of the interactive and automated data processing and analysis tools in HEC-MetVue. First, let's take a look at a few interactive tools, starting with the animation toolbar. There are the typical controls to play, pause, and stop the animation. There's also a slider bar with corresponding date range fields to mark the data display. You can interactively move the slider to manually scan through the data set or jump to any particular time of interest. The slider range initially defaults to the time interval of the data set. So if a data set is hourly, the slider will initially have a range of 1 hour to animate every time step. You can also choose the option to animate only the end date of the slider, which is very useful to see how the aggregate statistic evolves from start to end for the entire duration of the data set. And you can manually drag the end handle of the slider to create a 2-day range, for example. Then manually move the slider to scan through the data set and see how a 2-day aggregate statistic evolves. So, as you've seen here, there's a lot of flexibility and convenience in the controls to play animation or manually scan through the data set. When scanning through the data, edits can be made to correct the data. Here's an example of a grid set interpolated from gauging stations' point measurements. The northeast area is showing 300 inches of total precipitation over 3 days, which is not realistic and was caused by a faulty blip in the gauging station. For a quick fix, one can draw an edit region around the suspect area and apply an adjustment factor. We've touched on the spatial translation tool in a previous part of the presentation, but it's worth highlighting again how useful this could be to look at what-if type scenarios, especially in the case of hurricanes where there's uncertainty in their projected path. Take the Hurricane Dorian example you see here, where early forecasts projected that the storm path would safely skirt the New England region and not make landfall. Using the translation tool, one can play the what-if game and assess what the potential consequences of the hurricane making landfall could be. Such a hypothetical analysis early in the forecasting process would help with making emergency preparations should that situation happen. Comparative analysis is particularly useful in HEC-MetVue. Tiling multiple windows helps with visual comparisons of different forecast products, like this example here, where on-the-fly basin average displays show variations in precipitation volumes between different National Weather Service forecasts for the same period. Generating basin average time series is also helpful to compare forecasted timing of the precipitation between the different products. In fact, time series sampling can give a very valuable insight on the variation of storm intensity and timing over the affected areas. This can be done using the draw tool. Just pick any location in the map window and use the ad hoc context menu to sample a time series. Also, multiple points can be sampled at the same time. As you can see here from the Hurricane Florence example, the map windows show the variation in storm totals in space. Then, together with sample time series plots for various locations, it's possible to see when the storm affected different parts of the Carolinas. And it's possible to observe the duration and degree of storm intensities experienced at those locations. Now I'm going to touch on some of the data processing and automated tools and applications in HEC-MetVue. There's the MetInterp tool, which generates interpolated grids using time series inputs from gauging stations. The MetInterp tool requires georeferenced DSS time series records for input, and 4 different methods of spatial interpolation are available from MetInterp. Those are the inverse distance method, the inverse distance squared method, the nearest neighbor method, and the bilinear method. MetInterp allows for using multiple methods simultaneously to generate and compare interpolated grids. In general, the interpolation methods generate better results for more dense gauging networks, And interpolated grids can be useful for areas with poor radar coverage. Quite a number of HEC-MetVue data processing tools can be automated, including MetInterp to generate interpolated grids, and radar calibration using interpolated grids. The HEC-MetVue command line utilities can be used for setting up the automation. The most typically used utilities are Grid Reader to read and write various gridded data formats, and Basin comps to compute basin averages. Here's an example application of the Basin comps utility where it's automated to run every morning to produce a basin average map and text report showing the observed 2-day precipitation total for the headwater basins of the Fort Worth District dams. Another application is the MetVue dashboard for the Corps of Engineers Common Operating Picture, or UCOP system. UCOP is a web-based geospatial platform that provides a real-time picture of core operations across the country. And HEC-MetVue automated utilities supply the UCOP dashboard with rainfall statistics for headwater basins for all core projects. The MetVue dashboard in UCOP displays basin average statistics for observations in the past week and forecasts for the upcoming week. This helps provide situational awareness for core leadership and district offices, especially for emergency management preparations during extreme weather events. This is the end of this part of the presentation. If you have any questions about our software, need some help, or looking for additional training, please check out the links below, and thank you for your time.